I want to introduce you to the electrical installation training board. This board here is put together to simulate the domestic ring main, so the way electricity is brought into your house and then the way it's controlled so it links components together in your house so you can use electricity for your appliances such as lighting, cooker, shower, all the other electrical devices that you use day to day in your house. So first thing is, right, electricity comes into your house through these tails here. Now these are the tails that are installed by somebody who is working for the electricity board normally. They come into your house through very strong armoured cables that come through your house from outside. These cables are very thick, by the way. They're designed to carry a lot of current without overheating. And they come into your main isolator switch that's on your circuit board. This is called the consumer unit. So this consumer unit is a way of distributing the electricity throughout the house. So it's got this thing called a bus bar at the bottom, which is a common negative, and all the positive lines go off to different routes. So first thing then, right, so you get your very thick cables that come into your main terminals for on and off, which is where you can shut the power down for the whole house if it's on. Obviously this is not connected to anything, it's very dangerous if it's connected and live like this. Picking up then from the bus bar and the power lines that we've got different devices that can be used, and I'll focus on this for the first little introduction, that can be used to protect you in the event of something going wrong in your house. So we have these things called MCBs, they're labelled as MCBs. We have these things that are labelled as RCDs, and these things that are labelled as RCBOs. So I'll start from the left hand side with the MCB. MCB stands for miniature circuit breaker. Miniature circuit breaker. Now, a miniature circuit breaker, MCB, right, is a device that is a bit like a fuse, really. And a fuse will blow, so it's basically a thin piece of wire which is rated to a certain current. If over that current is sent through the wire heats up and melts quite quickly. Well, MCB is like a resettable fuse, basically, with too much current flowing due to a fault or something happening in a device. The current will overload and trip the MCB, the miniature circuit breaker. It trips and your power will cut off, and then you fix the fault, and if it goes back up again into the on position, stays on, then you know you're safe to use the appliance. So MCB, miniature circuit breaker, very useful, protects appliances really well, but not necessarily the person using them, okay? So if you're protected by an MCB, yeah, okay, it's going to protect the appliance, but it's not necessarily going to stop you having an electric shock, which could kill you, okay? So you're much better off if you're protected by something called an RCD. So RCD is a residual current device. RCD. Okay, so an RCD will trip at a much lower current and will, basically it detects an imbalance between current in certain part of the circuit, either flowing between live and neutral, or neutral and earth, or live and earth, and it will detect an imbalance in the current and it will trip off at a very low current and it'll save you from having an electric shock. So MCB, RCD, and the last one we had, which is an RCBO, which is a combination of the two of them. So that one is often used in a circuit board instead of wiring the two together, so your RCBO. So that's a combination of MCB and RCD. So those different devices now are sending power down different parts of our circuit. So I might have a loop connected to my first MCB, which is controlling my lighting downstairs. I might have a loop there on my second MCB, which is controlling my lighting in another part of the house. And I might have another one for my ring main that's in the kitchen, my ring main in the bathroom, whatever. So I'd probably be creating my RCD to have my ring main going to the bathroom, giving more protection against electric shock in a wet environment. So all those things, you can see how they're connected together and how they would send the power off down different parts of our ring main. So I'll talk a bit more about some other features of this in some other videos, like the earth connection and its role, and also how we send our ring mains to certain parts of the house, and why some of these cables are different thicknesses than others. So I hope that's a good starting point. Talks to you about the safety features in the circuit, okay, on your domestic ring main. Another thing we can go over with safety that's really important is our safe isolation procedure But that's for another video. Okay, that's it for now.